had well. Had a conversation before about making sure you know where you stand and why we have to go through and cover as much as we do to make sure that you all not only are just proficient, but you're meeting every challenge that you have, and when there's something in front of you that you haven't exactly done before, you have a good, a strong enough foundation with mathematics, and you can take that next step, even if we haven't, handheld, and I haven't mama bird regurgitating the worm into the baby bird's mouth to resolve these questions. We have not done this question or something like this since the first day. What do I have to do to answer out the first half of this question? Please, you can tell me. Seriously, one person? Oh my. What do we have to do to answer out the first part of question 1? Karen, what do you say?
I found the difference between the 15 miles per hour and 7 miles per hour.
Okay.
And then also the distance. That's very small. And then put that as a fraction of the slope.
That's absolutely right. You need to take the change in the y, or the output, over the change in the x. So if you didn't do that, we're going to go through and do that now. What did you get as your value, by the way? 15 over 2. Or who can tell me another answer that you gave, that's fine. 7.5 is fine. Make sure you put units on. Actually, no. The reach doesn't need units, but I asked that you put them on. What would the units on feet? Feet per miles per hour. Okay? That's what we went through and did. He took these 2 points here and found the average rate of change between those values. They're coordinates. Average rate of change is nothing more than a slope. And by the way, if you want to bookmark this, while I was looking for this question, who knows, maybe I found a terrific question that gave me 2 functions and asked me to compare the x-intercepts up. Hands up, please, and tell me how you find an x-intercept. How do you find the x-intercept of an equation? You might want to look it up then. We only have 3 people. Seriously? 4? Close. You just said it, and it should seem incongruous. You're trying to find the x-intercept, so you solve for y? Perfect. But that's what I mean, too, when you're processing it. You have the right idea, but when you're going through, if I'm solving for the x-intercept, should you be solving for the x? Now, if I need to solve for the y-intercept, by the way, who can tell me what I do to solve for the y-intercept? 3 people. She just explained it 3 seconds ago. You all should be able to pick that up. What? And solve for y. Yeah. Now, it's the second question is, what does this mean as it relates to braking distance? There's one little part of this that's going to be something that I'm a stickler on that you should have down. Nathan, what did you say for the B part of this? What does this rate mean as it relates to braking distance? Close. Ben, what did you say?
Speed increasing each 1 mile per hour, so does the distance it takes for it to stop while braking, which increases by 7.5.
This was tighter, right here. Every mile, now there's still something missing on yours though. Every mile an hour that you go more, how much more braking distance do you need? 7.5 feet. But that's not, I still need to add one more thing in there. Do you got one thing you want to add?
7 miles an hour.
It's not everywhere. That rate only applies from where to where? From 50 to 70. Now this student sample was a little bit easier. It said between 50 and 70, each additional mile per hour adds 7.5 feet more to stop. So if you don't have this in here though, the between, it's only going to get you half credit. But you're smart enough to give the whole thing. Does it apply universally? Does this rate apply universally? No, it only applies from where to where? 50 to 70. Is the rate of breakage feet or whatever it is that the same between 10 and 30? So that part needs to be there. This question right here was 4 points, this was 2, and this was 2. If this wasn't here, it was a -1. And the explanation about it being more feet to stop, you need to say that part. It's like more feet to stop. That was another point there. That's where the rubric came from. But who can tell me where the, careful, maybe I didn't take a good copy. 156.25.
But then why is there another one?
Oh, sorry. Wait, where did I do? 156, so I did this over this.
That's the first one should be 306.5.
Sorry. Is this what we had? Clear? Sorry if I screwed that up. Sorry. Is that better now? Is that what your question was on?
Yeah.
Okay. I want you in the future, this would be the type of question that could come up where you're going, we didn't do that. But are you a problem solver? Sure. Worst case scenario, get partial credit. I want first of all, the rounding fairy is a peach compared to the blank question bear. The rounding fairy, you may get seen again. The blank question bear, you know where he lives? He lives in a roof. And when you're not looking, he jumps off the roof and we never see you again. Can you imagine a bear jumping on you as you were leaving Schrader one day? Or maybe you're getting into a car. You're waiting for mom or dad outside. Your parents looks like there's something on the roof of this SUV right now, but whatever. They're driving along and go, oh, Ben. You open the door, mom or dad, super excited to see you, and you go, Ben, how was your day? And all of a sudden Ben's like, well, and this giant bear jumps down and drags Ben away. And they go, oh. And it's in the newspaper, local student missing from the blank question bear. And they go, what happened? Well, he left the question blank on the read. It happens. It happens. And let it be a caution to all of you. I don't want to lose any of you. It'll be very traumatic for us all. Now, next question up. Raise your hand if this looks familiar. How many times have you answered this question? Hands up, please, and tell me if you know the number of times you've answered this question. Too many? Sure. That's an adjective, not a number. How many? At least 2. I think 3. I think I put it on a test. It was on a review sheet, and then you had a test on the review sheet where I didn't change the questions. Probably 3 times, guaranteed 2. X is greater than or equal to 2. Now, what do we do to solve this out to start? Jared, what do you say? And then what are you going to do after you subtract the x from both sides? You've got to raise both sides to what power? Second power, yeah. You've got to go through and recognize that when I do this out, your goal is to isolate the radical, square both sides. Now this part on the right is going to get maybe a little bit messy. Anna, what's the right going to look like? Quad equation set equal to 0. Cassie, what's next? And what do you get? What's your new equation? And what do you do from there? Alexis? And what's it going to factor down to?
X minus 8 and X minus 4.
Can you keep going, or are you tired? Okay, just let me know if you're tired. What would you do from here?
You solve them, so X minus 8 equals 0, and X minus 4 equals 0, so...
She showed the factors equal to 0, and that should be there. I hate when people do this. Hate it. Because if you did this at any school worth a lick, you're not going to get points. They're going to scream at you. Not as much as I did. One thing, by the way, that's always funny. Raise your hand if you I don't care your opinion, but raise your hand if you don't mind. Don't be shy. I know I'm not. Raise your hand if I'm the loudest person you have all day. Raise your hand if you sometimes feel like I can scream. Now, you think I'm trying to get through to you? A couple of years ago, I had a class, at MCC of kids who literally at times, I think that they were just, that all of them had been in some sort of induced coma when they walked into the room. Like they're sitting there like this. And the duller you get, the louder I get. It's an inverse relationship. Yeah. So the less you give me, the louder I get. And they were so, I was like yelling, and I just remember the lady that's in charge. Somebody wrote on there, because at MCC you have to it's called student evaluation of teacher. And at the end of it, they wrote down, and I couldn't have been more complimented by this. You were the loudest and most arrogant and demanding something, bad adjective, you can't say it's bad traitor, person I've ever met in my entire life. But then the next thing was, I knew you cared because all of the other teachers get quiet when we get quiet. And I was like, oh. Yes, I do. And I went to go show it to the lady that's in charge. I go, look at this. Because I was crying. She goes, what was so wrong? I go, this person's trauma touched me. And she looks at it and she goes, we actually as a department wanted to talk to you about how loud you are. Because while we're teaching, we're hearing you as well. And it's not, they did not think that it was as cute as they did. You all right now are going to, by the way, if you have this on your paper, you are going to be getting a 6-point question. You're going to be getting 4. Can anybody tell me why? You're getting 4 out of 6 if you stop now.
You have to omit 8.
Yeah, I got that. I showed that. Why is this getting 4 out of 6? Even with that shown, you're getting 4 out of 6. How do you justify it? Thank you. Stop there. Plug it in. If it says justify, that doesn't mean give an interpretive dance. That means show me why it doesn't work. It's not an opinion. It's fact-based. If you don't have that step down, and again, I hate, when I go over with you all of your exams and stuff, there is not one person so far where I've gone, yep, you got exactly what you should have. Not one. I walked kids through tests and found, and one student in another section, we found 30 percent higher than what they should have gotten. 30. And it's stuff like, well, I circled A, but I meant B. Well, then there's, can I get partial credit on it? Now, imagine you go into the doctor, right? I know you needed to have surgery on your right arm, but I didn't on the left arm. Can I still get some money from you? You crazy? Get real. Now, let's go over. Have your notes out, please. Open to page 29. Section, are you guys free? Right. Check off today on the front. So again, that checklist is there for you and maybe and for me. When is your exam on this going to be? Hands up, please, if you can tell me. Do the count out on your own. When is the test for this unit going to be? Hands up when you can tell me. I don't know.
What day?
Today is the 20th, and it's a Friday, and it's a, what's today? B day? Okay. When is it going to be? Thursday. Plan accordingly. So that means it's going to be in this quarter. And actually, just so you know, also we have a quiz next class. 3 to 5 questions-ish. You know your stuff, are you scared? Get real. Now, read question number 29. Make sure you put down to, what's today? By day 5 is going to be a 1-20. And it's also a C day. You're answering out question on day 5, first question right now. Read what's there. Now, I need you to be able to pull out 2. In order to give out an exponential equation, how many points do we need? 2. You've got enough information to give out 2 points. Go through and find those 2 points right now. Read what's there, pull out 2 points. And hands up, please, when you can tell me the coordinates of the 2 points that we're talking about. 1, 2, 3, 4. Thank you very much. 5. Thank you. Read what's there. Be able to pull out 2 points. 6. Thank you. Sorry, the room's not quiet, so- What's 1 point? What's that? What's okay? So you want to say 10, 185,000. We've got another point then. What? Now, we could set this up and do all of this solving out. If you've got 2 points, can you get an exponential equation to go through there? Hopefully, yeah. And hopefully you can get it quickly. Does anybody know how I can use the calculator to help me to get an equation that goes through those 2 points? No? She's absolutely right. Now, you all, if I wanted it to be long, I want us to have time to get back your test at the end of the period. This would be y equals, sorry, instead of y equals, you would do 185,000 is equal to a times b to the 10 power, and then divided by 150,000 is equal to a times b to the 0, yada yada, solve that out longhand. You've got the calculator. Just go and take the regression, and let's round it to 4 places. So go into your calculators. Boy, oh, what could I do more to make it so you come in and sign into the calculator? You tell me. Should I get a giant sign? Should we have it be like you get a little zap? Like an air horn? And you think I'm joking, I have one in the car. You think I'm joking, I have one in the car. I'll sneak up right behind somebody who doesn't have it done, and we'll scare you. So you'll jump out of your desk and hit your knees as you stand up and fall over. That's the goal. Now, by the way, at one point, I did have an air horn in here, and I was told I'm not allowed to use it. Yeah. But whatever. Go into statistics, stat calculations, go down to A for exponential regression. What is our regression going to be when we round it out? Alexa, let's go to 4 places after the decimal. Whoever this is, you got to go through and get those from the drop down. So go and retake your exponential reg. And go in an arrow to the right. Yeah. So take your years and then whatever the stuff we're referencing. So go in and hit OK. And Alexa, let us know what you get for the equation rounded to 4 spots when you get it. Okay. To the where x is years. By the way, I look at this, is this exponential growth or decay? Hands up, please, when you can tell me what the rate of growth is looking at that equation. Eli? 2.12%, yeah. And that's the growth every year. Now, this is the part where y'all are going to screw it up. So you gave out this. How can you answer the second half of the question? What's the population in 25 years going to be? You're going to make such a terrible mistake right now. It'll break my heart. How do you figure out the population in 25 years? You really got to be a thinker. You know? Hands up, please, and tell me why she said plug 35 in. Anna? We made that initial point 0, 150,000. But technically, what could we have made our x value there? Negative 10. We get the same equation, but in that equation, I'd be plugging in what for x? Nope.
I believe plugging in or
To answer the second half of this question, if I use a negative 10 and a 0 here, then we plug 25 in regular. Now, here's a question for all of us. 2, 1, 2. What do you think I'm not going to see on a lot of papers that's going to break my heart? Disappointing person. You're right here. Well, that always breaks my heart. Yeah. Nope. Not even units. No. 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 I mean, I get over those things. They don't break my heart. What? No? I'm sure. Well, maybe you all are better than what I think. You don't show me out what you're plugging into the calculator. You just go randomly to an answer. You need to show the replacement in. If this 35, yes, the equation needs to be there, and the same equation with the 35 after it. Is that rocket science? No. Yes? Sure. What's your answer going to be for this? Amanda, what do you think? Let us know when you get it. Now, here's my question. It's 0.96 and change, right? Raise your hand here if you've ever seen 0.96 of a person strolling through. What is this city? Just the city. Maybe you see it in New York City. There's a lot of stuff you see there you're not going to see in Webster. Has anyone been driving through the village of Webster and go, Mom, Dad, quick, look, there's 0.96 of a person. Just like that conversation when I had with the graders about the deer. And they go, it's, it's a 42.6 deer. Oh, there's hunters. I'm assuming 0.6 of a deer would be much easier to catch with like an arrow or whatever your shotgun than a regular one full deer. Because wouldn't it run like a little lopsided, or maybe be running around without a head and most of its torso, something like that? You wouldn't be able to see, so it would just randomly run around. It would be so. Can you imagine? You probably want like 0.4 of the rounding fairy to show up instead of 1.0 of the rounding fairy. Now, one kid asked this question. Was it 6 there? One kid asked this question too, and it was a good question to ask. And I get lazy with this because I get so preoccupied with finding good questions. I always forget to put something in there. We discuss it sometimes. Who do I always forget to put in our questions? Wrong. I get so preoccupied with it. But you know what's good? Every class we round different. You get to pick probably. But this one we should know for the people. Now, I want you to answer out this question right now on your own. Go through and answer out that question on your own right now. And by the way, let's see. Noah, how far do you want us to round? Oh, sorry, never mind. It says the rounding on it. Sorry, Noah. Next rounding you get to pick, all right? I hope you're not upset. Did we discuss the meeting that we had with the Thomas people the other day? How we're going to slaughter them on the exam? I was telling Miss Coit down in the math lab, and she goes, you think that's funny? They'll make you go over there, and you'll have to teach all of their kids, too. I go, when am I going to even eat lunch? So probably won't. I'll have to teach every class over at Thomas, and then come over and do more at Trader. I'll be so busy. It'll be terrible. Eli, how many questions are there to answer on that last one on the page? No? You can tell me how many there are. Really? Really? Christina, how many questions are you going to have to answer that last question? Not one. Eli, how many? Two. This is another bad habit that we get into. The read is going to give you, most of the time I'm noticing, they're going to give you some huge narrative, especially towards the end. So brace yourself. There's going to be a heck of a lot of reading. And again, it's very situational. So you're going to go through, there's all this reading, label the questions as you see them. So take a look what I did. I put a 1 there and a 2 there. So you make sure you answer everything. What is our answer going to be for 1? Erica, did you get an answer for 1? What's the equation going to look like? 10 thousandths, which is how many spots?
14.97.
Keep going. 10 thousandths is 4. Should be 6, 7.
Yeah.
Okay?
0.9559.
There we go. She's absolutely right. I put an approximate sign on it ever since I got yelled at by that gentleman at the University of Rochester. Why is it an approximate sign? Because it doesn't actually equal it. We're using an approximation. On the REAG, they're not going to care. They are so lackadaisical in this state. And we sit there at the test writing committee. And they're like, oh, it's good enough. You think you all are difficult. Oh, terrible. They write questions that are wrong. The state last year had 2 questions on the exam that they had to give everyone credit for. Why? They're wrong questions. The questions were wrong. Let that sink in. What do you do to answer the second part of this, Leah? And what'd you get? Who's got it? You have it? Okay. Questions on that? Now, next page. When we do this one out, this is always interesting. So it says the data shows the average growth rates of 12 weeping, what? Something trees, whatever. Trees. They're trees. What are they called? Hanging? Whatever. Doesn't matter, right? By the way, I love it. Some kid came over to me once last year on the geo exam, and there was something like the word, it was so inconsequential to the question. And he's like, how do you say this word? And I'm like, I don't know. Well, I can't answer the question then. I'm like, you don't even need it. So literally I took the pen and I crossed it out. I go, now answer it. Now, at the time of planting, the trees were 1 year old and all were 6 feet in height. What model best suits this? So here's the age of the tree and there's the height of it. Now, what type of model suits this? Now, you've got 3 choices. It's either linear, exponential, or logarithmic. What do we want to say about linear? If the growth is linear, what should it look like? Let's say that if this table represented linear data, what should it look like? It's not going to be exact because it's real world data, but it would be approximate. If this data were linear, what would we be seeing? Go ahead.
Every year, it would increase at the same rate.
About the same rate, because it's real world. So, 1 year it might be 0.5, then it might be 0.45 and 0.6. That's about the same. If it was exponential, what would it look like? See? It would be going up by some multiplier. It could double, it could triple, it could be multiplied by 1.5, something. If it was logistic, remember what your log graph looks like? It's the inverse of the exponential. Now, let's do this. And I had one of you buttes show me how to do this before, so I need another one to do it. But I need you first to go in, get me a new table, and plot this data. Or sorry, plug this data in to a table. And make sure we label it correctly. One is age, one is height. So go into your calculators. Don't vacantly stare at me. I know I look good. Now, who here knows how to, raise your hand, we're not yelling, who here knows how, please, to input the data, who here knows how to input the data so I can turn it into a scatter plot, or what I have to do once I've input the data to show a scatter plot? Do any of you know? Darren, you know, let's see. Let me see where you are on this list here. Do you see yourself? There we are, right here, right? All right, you're going to be our showcase model. Now, it's a ton of pressure, and I'll warn you from experience. The people in this room are vicious, and they're very judgmental. Oh, my God, what'd you even do? All right, can you go back to the beginning? Walk us through from the beginning. Yeah. Walk us through from the beginning what you did. Oh. Okay. So what'd you go to? What'd you hit first? Okay, so hit menu, go to data, and then what'd you do? Quick graph 9, okay? And then do you have to click on over here or something to make them change? Is that right? Yes or no? Okay, so that's going to be our height, and then select down here to make it the age. Now, there is another way to do it, too. Does anybody know how to do it so this doesn't show up? Who knows? Do you know how to do it? Hang on, let's do it. I just don't like, this is right, but I just don't like how condensed it is. So let me do this. Oh, Amanda, you got yours. Okay, go back to the beginning, Amanda, and show us what you did to get to your screen. So you went to this. What'd you do to? Data. Okay. Go down below and select the height. Oh, okay. And now change that to be your height. Now, is that linear? Is that exponential? The inverse of exponential. What's the inverse of exponential? The log. Now, you need to come up with, so let's answer that piece first. What type of model suits this? Logarithmic. Why? Here's what the data does, right? That's a log graph. Now, what's the average height of the trees at 1.5 years of age? Now, we're trying to find something to model this. What equation, or what type of model did we say this was? Log. So let's go through and determine what our log regression is going to be. It's not looking for the average rate of change. It's looking for what's that height going to be. So find an equation to model it, and we're going to plug into that equation. Now, this is the part where you've got to make sure you bring your A game. Go into your calculators, please, and go to your screen there, and press, go to your stats screen that was on. And you're going to go in and go to menu, go down to statistics, which is 4. We're going to run a stat calculation. Which choice am I going to pick? Well, scroll down. Which one says log regression? There you go. What's our X list going to be? Age. And our Y list is going to be height. Scroll down now. And by the way, who did we say? No, was that you that's going to round this time?
Yeah.
Okay, how many spots after the decimal do you want?
3.
3? All right. So here's what the equation would look like to 3 decimal places. Go over to this. By the way, if you put your cursor on this, it's going to tell you what you're filling in for. It's A plus B times this. You can't add the A and the B, by the way, because it's B times. So this would be, what would we have as our equation? Jared, if we rounded to the, you said 2 places?
It's a 3.
Three places. What are you going to say? What's the regression equation going to be rounded to 3 places? You can tell me what that equation is going to look like. Seriously? Yeah. 0, 3, 0, okay, plus?
Natural log.
And I love that you aren't saying ln. I love that. Let's make sure we don't ever do that. And when other people do say it, what do you say to them? What?
Yeah, you don't say anything, you just throw it down.
You could throw a desk if you want to, sure. You could become outraged and tell them you're outraged and offended.
Why is the L and not an L?
Because it's Latin. It's another language. Now, what's the average height after 1.5 years? So how would we figure out the answer to this? All you gave me is a regression so far. We got one person? Seriously? You didn't answer the question yet. Anna, what do you have to do to answer this question? Perfect. You're going to give the exact same equation, and you're going to replace the x with the 1.5, and yes, you're writing literally the same thing, with the 1.5. You could also do 3 over 2. What's the average height? Now plug that in, and let's evaluate it out. And by the way, I'm going to do the bar trick on that. I'd advise you to do the bar trick. Plug in the expression, put the bar, and then x equals. I know this person did it correctly. Into 3 places, I'd say 8.589. So this would be 8.589. Questions on that? Next one. Predicted at 20 years of age. Is this realistic? So what would we do to answer this question? Cassie? Plug 20 in for x. What do you think about people who don't show the equation with the substitution in? Would you talk to them? I wouldn't. Who can tell me, please, what this is going to come out to be? We got 1. If you did it as a bar, it's easy. What do you want to say? 3 places. 24.397. Is that realistic? Yes or no? Look at the data. Is it realistic? Yes. Do trees get to be, after 20 years, is it reasonable for them to be 25 feet tall? Probably. What's an answer that doesn't make sense? One like 5, because that means the tree magically got shorter. That, just so you know, doesn't happen if you haven't taken biology yet. Another thing is, what if it was like 1,000,000? Would that be? That probably would not be true either. Now, one other thing that we need to go through and say before we go back, and I love you think, what's the difference between interpolate and extrapolate? We said it before. They're big words, and they make you sound really smart, and it's such a low-level concept. 2 people remember? You're not wrong. I think I know what you're hitting at, but you're not there. We can tighten it up. No. What do we think interpolate means versus extrapolate? You were closest so far. What do you want to say?
Interpolate is inside x equals 1.
Inside what? The data that's given. So like looking at what we have data from 1 to 11. So it's 1.5 inside of 1 and 11. inside the data set? Is 20 inside of that data set? No. Interpolating is much more accurate than extrapolating. Okay? Now, yes, we're done with this. We still have a bunch of stuff we haven't done yet. Like, go over to page 27. Take a look at the question at the top of page 27. Hands up, please, when you can tell me what we're going to do to get an answer to what's on top of page 27. So far, I've got 0 persons. Fabulous. Oh, outstanding. What?
You're gonna multiply x plus 5 plus x.
This log side needs to be condensed down. So this would be log base 6 of what? Fill that in for me, please.
X squared plus 5x.
Thank you. What gets done next? Amanda? Noah, what's next?
Subtract 36 from both sides.
Hands up, please, if you can tell me what's next. One person, get real. 3. Abby?
You would solve that and it would be x minus 4
And what?
x plus 5.
Not 5.
That's something else.
9. What do we do next? Eli? So we get answers of x is equal to 4 and x is equal to negative 9. Go back and check both of those answers right now. And actually, I'll say this. You really don't even need to go back and check. Look at what's there. One of these answers won't work. Hands up, please, and tell me which answer is not going to work. Which answer do I know is not going to work? Why? When you plug that in, the argument becomes negative. The 4 does work, just so you know. We're going to hopefully burn through this last one quickly. Solve this equation out. What would we do to start this one off? Hands up, please, when you can tell me. Next one. Ed? And then do what? You're right. What now?
And then do 3, and then do e to the
Not yet. I can't yet. I got one more thing I got to handle.
base 3, and you repeat it to
Instead of doing that, who can see something else you want to do? You're going to get to the same answer, but this makes it less complicated. Divide both sides by 3. Now my natural log is alone. So this is the natural log of x minus 3 is equal to 1/3. I'm going to exponentiate this. So this is e to the 1/3 is equal to x minus 3. Add 3 to both sides. This is your exact answer. Could you type in and get what that comes out to be as a decimal? Yes or no? Fabulous. Now, I wanted to make sure we got through all this. I think I wish we had separate time to hand out tests and garbage in here. Now, hand these out, please. Thank you. Hand these out, please, and thank you. Hand these out. Thank you. Thank you. The group assignments, make sure that the people get them back, know where they are. Here you go. Let me hand this. Yeah. Hand these out for me, please. Thank you. You hand those back. Select for them. You hand these out. Hand these. So much stuff from a month ago. Millennium. Those out. Get these out. What? Okay. So it's a long one.